Okay. Now the next problem that we are going to take in static structural analysis is for an assembly. Now we will understand how to analyze an assembly in static structural analysis. So here we have taken an example of a C-clamp assembly. The dimensions of each and every part is mentioned over here. These are the dimensions. You can write down the values in your notebook. You can check the values. Okay. And according to these values, you can also create the same model in a CAD software. You can create the assembly. Okay, now you can see the details over here. We have 4 components in the assembly. Okay. The components are also marked over here. Okay, and after that you can see the boundary condition data and other data for the assembly. Now we have marked 3 phases over here: phase 1, phase 2, and phase 3. Now there are forces that is acting on phase 1 and phase 2, which is of 3000. One is acting in the upward direction and one is acting in the downward direction. So that is the force boundary condition. And then we have one boundary condition on phase 3, that is a fixed support. Okay, so phase 3 is fixed. The material properties are given over here. All the components except the pin are made up of a material called as cast steel, whose Young's modulus is 2,05,000 megapascal and Poisson's ratio is 0.265. The pin alone is made up of structural steel. Okay, so now we will analyze this. We have to apply these loads and then we have to understand what are the stresses induced in the model. So let us add this assembly. So now this assembly, I have already created this assembly in a CAD software. After that, we will first change the engineering data. We have one structural steel. We need one cast steel. Okay, we need the cast steel whose modulus has to be 20500. Okay, but make sure that you change the unit system. We have to give it is megapascal, so make that necessary change. It has to be into megapascal. So enter the Young's modulus value, make sure the units are correct. After that, enter the Poisson's ratio. It is 0.265. Okay, so same we have entered over here. Okay, after that we'll return to the project and now we will call for the geometry. So as I said, the geometry, I have already created that assembly which I am going to import now. So I have this I have the C-clamp assembly folder over here in which I have saved it. So this is my assembly. Okay, you can just check the assembly whether all the components have come correctly or not. So we will enter into the design modeler, set the unit system and generate the design. So you can see that this is my assembly which I have created. All the parts have come correctly. You can also see that the names are also there. So I don't need to rename them. Okay. Now once the assembly is updated, now we will enter into the mechanical model. So we will enter into the model cell. And now we will perform the meshing first. So let the model get updated. So once the model is updated, now we will perform the meshing. But even before we perform the meshing, we have one more thing to take care of over here, that is the contacts. So let us see the contact regions that have been created. Okay. We have one contact over here which is between the swivel and the screw over here. I will say that these two contacts have a bonded contact region. Okay. Then contact region 2, which is between the pin and the screw. I will say that they have a no separation contact, means they are free to slide. And contact region 3, which is between the screw and the C body, again I will say that it has to be no separation. That means it can slide over here. Okay. After that, I will click on meshing and I will update the meshing. So in the first case, what will happen? I will get default mesh settings for everything. Okay. Every component, I'll get the default mesh setting. Okay. After which, now what we can do is we can use the sizing option for generating unique or uniform mesh size for every component. So I can say the mesh size for this is, let me change my unit system to mm over here. So in this case, my unit the element size is 4, or let us say 2 mm, and let me add one more automatic size. I need to have a sizing control for this body. The element size should be 3. Let me update the meshing. So you will see it has become much more refined. Now we are left out with the shaft, this screw. So I will add one more sizing control. I will select this body, and even here I will set it as a 2, and we will update the mesh. So with this, we have now got proper refined mesh on every component. Okay. After this, now we will go for the boundary conditions. So as per the problem, I need to give a fixed support on this end, and I need to apply forces in this direction. On this value is 3000 Newton, and the direction has to be in the opposite direction, and the same value, same magnitude force is acting on this face, 3000, and the direction should be in the opposite direction. And after that, I would be interested into the total deformation and equivalent stress and the maximum principal stress. And now we will say solve. So even in this case, the runtime for the analysis will be quite high because we have more number of components and the meshing is also very fine. So it will take some time to solve this analysis. So now you can see we have the equivalent stress at this region, which is very high, 2908 maximum principal stress and the total deformation. Okay. So if I add one support from here, and now if I again solve this analysis, you will see that the results will differ. So now if I say that even the base is fixed, it is rested on some other support. Okay, now look at the results. So now the equivalent stress that we've got is 68.1 megapascal. The deformation is 0.01 and the maximum principal stress is 81. Okay, so did you understand how if I did not give this support, the stress value is quite high. Okay, so now this object will be rested on some other object and then we will apply this, we will be pushing down this rod. So a simultaneous resultant force, opposite reaction force will be applied over here. Okay, so with this example, now you have understood how to perform a static structural analysis on an assembly. Okay, you can also calculate the reaction forces. For reaction forces, you need to go to the probe option and you need to say that I want to calculate the reaction force and I want to see the reaction forces on fixed support. Solve it, and now you can see the values. Similarly, I want to see the reaction force for fixed support 2. You can also see both the reaction forces. Okay, so this is the reaction force. You can also see the animation. Okay, now whatever animation you see over here can be exported to a AVI file. You can write the name for this. I will say that this is reaction force. Give a saving location and save it. So the reaction force video will be recorded and you can also see this video. So that is the video. If you want it for some more time, you will have to change the time over here. Okay, I want it for 10 seconds or you can increase the number of frames and then again you can record it. Okay, or you can export it. You also have something called as the results that you get. If I want it in contour bands or smooth contours, you can see. If I say contour bands, you will see it like this, smooth contours, or they should be just iso lines or no color. These are all post-processing tools which we can use. I want to see the undeformed model as a wireframe mode. Can you see this now? Or I want to see it as model. So you can see that the undeformed model is also seen. You can see a background of your undeformed model over here. Okay. You also have something called as probes. The maximum probe and the minimum probe, which shows the location of the maximum stress value and the minimum stress value. Or else you can use a manual probe. Just click anywhere and you will see what is the value at that region. For example, I want to see what is the total what is the deformation at this point, what is the deformation at this individually. Even for that you can use it. Okay. So these are some of the post-processing tools which you can use for your result viewing.